We're going to see now how to approximate the area under the curve using trapezoid approximation. This would be, let's say we have the equation y equals root of x. This is the graph. We are going to approximate this area under the curve. It would be from here to here, let's say, using trapezoids. The trapezoid will be, well, here would be a little bit difficult to say it, so let's do it from here to here. So this will be one side of the trapezoid, and this will be the other side of the trapezoid. This and something like that. The next one will be from here to, let's say, here, and this. Next one from here to here, and we have this to here, like this, etc. This is just kind of the same. So maybe I don't put the same white. The important issue is that, as you can see, the area with trapezoids will be a little bit underestimated. We here have some area that is not being covered, so it would be underestimated. Alright, now anyway, how are we going to approximate this? Remember that the area of a trapezoid is the sum of the sides. This is one side and this is the other side. So let's say, I don't know, B1 plus B2. Let's say that this is the side divided by 2. Or actually, now for this one would be this side is f of x sub 1 plus f of x sub 2 divided by 2. I'm sorry, and I forgot, is this times the y, the x. This is due to this f of x1 plus f of x2 is divided by 2 is half the height of, here we have one trapezoid. We have this. This is, if you break it up as like here, anyway, or a little bit higher, well, you can see that we have the area of the trapezoid can be approximated as a rectangle and a triangle, but this is not the important thing. The important thing is that the height of this is base, sorry, the area is base times height. Now, how do we find the height? The height is this height, so it's half of the height from here to here. So it's this plus this divided by 2 is going to give us this height. So for that is, here will be f of x1 plus f of x2 divided by 2 in order to know this height, and then times the y. The y, let's call it dx or delta x. So times delta x. Next, the area of this rectangle of this trapezoid will be again delta x times f of x2 plus f of x3 divided by 2. Next is delta x of f of x3 delta x times f of x3 plus f of x4, etc. divided by 2, etc, etc, etc. So what can we factorize? We can factorize dx over 2. So we have dx over 2 times f of x1 plus f of x2 plus f of x2 plus f of x3 plus f of x3 plus f of x4. Let's say we're calculating 1, 2, 3, 4 from here, the area under the curve from here. So we have dx, delta x over 2 times f of x1 plus 2 f of x2 plus 2 f of x3 plus f of x4. This is how we approximate the area under the curve with trapezoids. We will do delta x if we know how wide it is. Each rectangle, we will do an example in a while. It will be delta x, the width of each rectangle divided by 2, times f of x1. Now f of x1 obviously will depend if we are beginning from here or here, but also it will depend on how much is delta x. If delta x is 2, and let's say if we want the area under the curve from x equals 2 to x equal 6. So and we have that our delta x is 3. So if 2, our delta x is 2. If our delta x is 2, here it will be f of x1. x1 is 2. Will be f of x1, f of 2 plus 2, f of x2. x2 will be 2 plus 2, 4. So f of x2 is f of 4. F of 4 plus 2 times f of x3. Now will be, we got 4 plus 2, f of 6 plus now x in 4, x3 4. That is sorry. Let me put it from 0 to 6. This was the problem I got in mind. So just because we cannot put 2 intervals like that. So let's do it from 0. So will be f of x1 will be f of 0 plus f plus 2 f of x2. x2 will be 0 plus 2, 2 plus f2 f of x3. x3 is 2 plus 2, 4 plus we are at the last one, and as you can see we have 4 plus 2 is 6, f of 6, and here we do not put the 2. So this is a little bit difficult to see, but let's do completely the example. Let's say we don't have this equation anymore. We have y equals to x minus 3 squared, and we want to find the area under the curve from this, from x equals 0 to x equals 6, with 4 equals sub-intervals with trapezoid method. So first we have the graph will be here and x squared, something like this. The range is from, the domain will be from x equals 0 to x equals 6, let's say here, with 4 sub-intervals. So the rectangles will be 4 rectangles. Now how wide is the rectangle? We know that from here to here is 6. So how much each rectangle measures? 1, 2, 3, 4. So will be the last one, 6 minus 0 divided by our rectangle. This would be delta x. So delta x is 6 divided by 4 will be 3 halves. Or in order to do it simpler, we could have from 2 to 6, and so will be 6 minus 2 would be 1. But alright, anyway. Alright, now that we have delta x, we have delta x will be 6 minus 2 is 4 divided by 4 is 1, and so we would have 1 divided by 2 times f of 2 plus 2 f of 3 plus 2 f of 4 plus 2 f of 5, because we are just adding 1, plus f of 6. And as you can see, we have 4 intervals, 4 rectangles. One is this one, the other is the other is this one, the other is this one, and the other is this one. Remember that here we have 2f3 because we have this one, like this. So we have 4 intervals. So that's correct. So now we should just evaluate. What f of 2, we have 1/2 times f of 2, 2 minus 3, 2 minus 3 is minus 1 square 1. Now f of 3 will be 3 minus 3, 0 times 2, 0, plus f of 4 is 4 minus 3, 1 square is 2, 2. And here 5 minus 2 is 2, square 4 times 2, 8, plus f of 6, 3, square 9. So this is 1/2 times 9 plus 9 plus 2, this is 18, this is 20, divided by 2, this is 10. The area on the disc will be 10 units. Yeah, I hope not to have committed any mistake, a silly mistake, arithmetical mistake, but I think that you got the idea, and if I made a mistake in some arithmetical, you will catch it and you will know that you're right. Just the idea is what you want to take from this video. In the next video, we're going to calculate the area under the curve with midpoints and right and left Riemann sum.